Yeah, today I want us to talk about thermal expansion. Now, when we talk about thermal expansion, we will need to understand the two terms, thermal and expansion. Now, the word therm means heat energy. The word expansion means increase in size. Now, this topic basically will talk about how heat energy can lead to change in the size of a material. Now, one thing we know about matter is that when matter is heated, it leads to expansion. Basically, the size of that matter will increase. And when you cool matter, the size reduces. That reduction in size is called contraction. So we are having two terms. We are having expansion and we are having contraction. Now, both of them have something to do with heat energy. Either heat energy is increased or the heat energy is reduced. If there's an increase in heat energy, there will be an expansion, which means increase in size. If there is a decrease in heat energy, there will be a contraction, which means decrease in size. So in this topic, the first thing we are going to talk about is the temperature. So what is temperature? When we talk about temperature, temperature means the degree of hotness or coldness of a material. On a particular day, the heat content in a particular material can change. When a material is hot, it means the heat content in it is so high. Therefore, the temperature will also be high. If a material feels cold, then it means the amount of heat energy in that particular material is low. Therefore, this particular material will record a low content of heat, which translates into low temperature. Now, the SI unit of temperature is Kelvin. I want to make something clear here. When we talk about the SI unit, we are used to temperature being measured in degrees Celsius or degrees centigrade, but now we have an SI unit. So temperature, the SI unit is Kelvin. Kelvin is denoted by capital letter K. So the degree C is just a unit that can be used to express temperature, but it is not the SI unit. So let me take this again. We are talking about temperature. We need to know how to define temperature, the degree of hotness or coldness of a body. And it is measured in a unit called the Kelvin. So that Kelvin is the SI unit. So I want us to be very, very clear on that. Now, temperature also is one of the 7 basic quantities that we discussed earlier. The reason why we say it is a basic quantity is because it can be measured directly. There's an instrument you need in order for you to be able to measure the temperature of a given body. And this instrument is called the thermometer. So if you have the thermometer, you can measure and quantify the temperature of a given body. So because of that, we classify temperature as a basic quantity. So the first thing I want us to look at is expansion and contraction of solids. When solids are heated, their temperatures increase. And when this temperature increases, the solid will expand. When solids are cooled, their temperature decreases. Their temperature will reduce. When there's a reduction in temperature, the solid will contract. Now, there's various experiments that can be put forward to explain this. Number one, we have what we call the ball and ring experiment. Ball and ring experiment, it's about a ball. So I want us to look at it. You can look at it here. So we are having a ball. There's a ball here and there's a ring here. Now the ball and the ring are having the same diameters. They have the same diameter. The diameter of the ball is equal to the diameter of the ring. So if we hit this ring, let's say we take this ball and we put it on top of this ring, it will fit into the ring. Now, if we start hitting the ring, we will make an observation that the ball will start slipping through that ring. It will go through the ring. The reason why it is going through the ring is because when you hit the ring will expand. So the diameter of the ring will be bigger than the diameter of the ball. For that particular reason, this ball will simply slip into the ring. If you do it the other way around, you put the ball onto the ring and then you start hitting the ball. If you hit the ball, it will expand. The ball will start expanding, and then eventually the ring will also start expanding because they are in contact. And after some time, you can see the ball fitting into the ring and passing. So when the ball passes through the ring, we can say at that point that the ring has expanded. So that expansion of the ring, which has made the diameter of the ring to be big, that is what has enabled the ball to go through the ring. So that is one of the experiments that we can put forward to explain that indeed when you hit solids, they expand. So if you hit the ball, let's say you hit the ball separately. You hit the ball where it is, and then you bring it onto the ring which you've not heated. The ball will settle on top of the ring. But after some time, it will start going through that ring. Now, get this properly. When the ball is on top of the ring, remember the ball is hot, it was heated, it has expanded, and then we put it on top of this ring. Heat energy will be transferred from the ball into the ring. So gradually, as the ball loses that heat energy to the ring will expand. As the ring expands, the ball will start contracting because it is losing some of the heat energy. As a result, we are likely to see the ball again fitting into that particular ring. So there are two things here. When you hit the ball separately, it expands. When you bring it onto the ring, it cannot fit into that ring because the ring is having a smaller diameter. Then, when you rest it on top of the ring for some time, it will start losing heat energy to the ring. So as a result, the ring will start expanding. Now, as that ring expands, because it is gaining the heat energy, the ball will be contracting because it is losing heat energy. After some time, we are going to have their diameters being equal once again. So the ball will fit into the ring and eventually pass through the ring without any difficulty. Another experiment that can be used to demonstrate expansion in solids is what we call the bar and gauge experiment. Now, there is a gauge here. So I want you to look at this. There's a gauge here. You look at that experiment. There's a bar. This bar has a handle. The bar has a handle. Now, the length of the bar from this point to this point is equal to the length of the gauge from this point up to this point. So under room temperature, when you hold the handle, you can slip the bar into the gauge. It will fit. You can look at this. It fits into the gauge without any problem. But now, if we take this bar and then we heat it, maybe using a Bunsen burner, we heat the bar. The next time you bring the bar after heating, you try fitting it into the gauge, it won't be able to fit because it will expand and it will become longer. So it will be, maybe it will expand up to somewhere here, and this side also maybe up to somewhere here. So when you try pushing it into the gauge, that will not be possible. Now, the reason why it is not possible is the bar has become longer because of the heating. The gauge has not been heated, so it maintains its length. So when you take that gauge, when you take the bar and you rest the bar on top of the gauge, we are going to make the same observations as with the ball and the ring. When the gauge is on top of the bar, remember there's a temperature difference. The bar is at a lower temperature. The bar is at a higher temperature because we heat it. The gauge is at a lower temperature because it was not